Good afternoon, students. We are going to talk about the mechanical properties of solids. So, by mechanical properties, what we mean is that we are going to talk about the deformations of solids, and we are going to talk about the stretching and bending of solids. So, in the previous chapters, you have learned rigid bodies, and rigid bodies are defined as the ones which have their interparticle distances which remain constant throughout the course of motion. However, that does not stop bending or stretching or extension or even other kinds of deformation of the body. Now, these deformations can be brought about by the application of forces, even the steel rod, which is known to be quite strong, can be deformed if the applied force is very large. And we are going to talk about two kinds of deformation mainly, one in which the body actually regains its normal configuration once the force is removed, and one in which they do not regain the normal configuration. Mainly we are going to constraint our discussion on the forces which after which if it's removed, the body is going to will regain its normal configuration. So, these are temporary deformations, and mostly we are going to talk about these temporary deformations. All right. So, let us take an example of bungee jumping. Have you heard of bungee jumping? If you haven't, then you might as well want to look at a video in YouTube about bungee jumping, in which what happens is that a diver or a jumper, he or she binds himself or herself along with an extensible cord, and then take a dive from a very high distance or large distance. And this is typically of the order of maybe even a few hundred feet to even more than that. This could be a dangerous act, so please do not try without adequate supervision by professionals. We are not going to talk about the problems that it could bring if a body suddenly jumps from a few thousand feet to the ground because of the pressure difference. Rather, we are going to concentrate on the amount of or rather the material which the bungee cord is made of, and the bungee cord is made up of a material which has a great a deal of elasticity. In this video, the boy is seen to give a bungee jump. So, he falls off from a large height. He is tied with a rope. So, so what happens is that as the diver or the jumper jumps from a height, the cord, bungee cord, which is elastic, it keeps getting elongated more and more till it reaches a point which is its maximum elongation, and then the diver comes to a temporary halt, and after that he is going to swing in an oscillatory manner, and this is what makes all these bungee jumping very spectacular. So, so after this initial fall, the jumper actually comes to a momentary halt, and then this cord, as I told, that the cord is stretched to its maximum, and then there is an oscillatory motion that is going to take over, but this oscillatory motion does not carry on forever, and viscous drag due to air and other wind, etc., would take over, and then finally the jumper comes to a complete halt. So, this is this bungee cord is made up of a material which has got this intrinsic property of getting extended because of this force, or which is basically here the weight of the jumper, and then the cord is going to regain its original shape, and that is why the oscillatory motion occurs. So, it is from this discussion of this bungee jumping, it is clear that it is a property of the body by which it tries to regain its original shape and size after the applied force is removed, and this is called as an elastic material. So, what could be the examples of elastic material? Such as we have a rubber band